Hello everybody, welcome to today's presentation. I'm Theodore Skide. Today I'll try to present about week 5 part 1 video, which is new chapter, manual transmission gearbox or transaxle. At the end of this chapter, you must able to define function of transmission system and explain its role, identify different types of gear arrangement, describe how power flows through a transmission. You can able to calculate gear ratios, identify different types of gear shifting mechanism, and describe the function of shift interlock mechanism. Perform tests to assess the condition of manual transmission and conduct servicing. Identify common transmission problem and their symptoms. Demonstrate the steps involved in overhauling manual transmission. This will be a short objective of the overall chapter. As a whole, to achieve this objective, we have all this content which is covered with a series of video: the transmission overview, gear arrangement, power flow, gear ratio, gear shifting mechanism, shift interlock mechanism, test and service manual transmission, diagnosis, and the last will be overhauling the manual transmission. So I will try to cover this part in the upcoming videos. In this part, we will try to see the first one, transmission overview. When we see the transmission overview, obviously the transmission is one supporting system for the operation of IC engine, because an IC engine used in modern vehicle will operate a limited effective speed range. When we say a limited effective speed range, according to energy efficiency, or which means fuel efficiency, emission efficiency, and maximum torque output, cooling system efficiency. If we see from this different perspective, the engine will have limited effective speed range. In some cases, the speed range even it approaches 1,000 to 7,000. Most commonly, but in this part we will see 1,500 up to 7,000. So when we see in the perspective of torque, the engine will produce a comparatively low torque or turning effect to meet different driving condition of the vehicle. Even if the vehicle, if the speed is dropped below or limit, the load will be great and the engine will be stalled. So to compensate this one, the vehicle employs gearbox. Even if to stand from the rest, it is difficult. When we see the performance curve and fuel consumption of the IC engine or spark ignition engine, for example, here, if we observe with the range of RPM, the brake fuel specific consumption, the fuel consumption, if we consider this one, almost the better one is obtained at the mid, which means 1,000 up to 7,000 RPM. If we see also in the perspective of torque, which is the center part will have higher torque, at the same time the better performance is obtained in different perspective at the midpoint, like indicator power, brake power, frictional power. Even if the indicator and the brake power is increased, or even if the indicator power increases, if you observe, the brake power will decrease due to the increasement of frictional power, and this frictional power leads to overheating of the engine. So which means we need to initially check the efficient operating condition of the engine. So simply this is why the gearbox is employed. When we come to manual transmission, the basic function of manual transmission is to transfer power from the engine to the propeller shaft through the clutch, and it converts and multiplies rotational speed, it converts torque, it allows the engine RPM to remain in limited range. That's why in some vehicle speedometer it shows, tachometer, it shows green, white and red. So which means the green part is the prefer level speed, like the lower, and the that's in between the lower and the higher RPM, so this one is critical. The gearbox uses multiple gear sets within the transmission, provide gear ratio, which means utilized by the engine torque. It can adjust the proportion of torque and speed delivered from the engine to the drive shaft. Let's have one daydreaming activity. What will happen if a vehicle did not have a gearbox? What will be the critical disadvantage? If you observe this, or if you ask yourself this question, let's look some reasons. For example, if the vehicle didn't have any gearbox, the following disadvantage would become apparent. For example, poor acceleration from rest, which means the vehicle cannot accelerate easily, because to accelerate it requires extra input, and to have that extra input it must have some torque multiplication mechanism. That's why when we start from rest, the vehicle uses higher gear ratio, then the gear ratio becomes lower, so which means from lower gear to higher gear. The next one is poor hill clamping ability. That means the engine output torque is lower in real condition. If you observe in fifth gear, we cannot climb here, but instead if we use first or second gear, we can climb hill. The next one, vehicle cannot be driven at low speed. Even if you observe the idle speed, the lower idle speed of the vehicle is around 850 up to 750, something like that, but the common one is in most vehicle 850. If that drops below that 850, 700, something like that, the vehicle will be, the engine will be off. That means the vehicle cannot be driven at a lower speed. No neutral or reverse will be obtained. So if we agree on the availability of types of the availability of transmission, let's try to classify types of automotive transmission. It's to give you some clue, but in detail we will see this one in chapter 4 parts. Depending on fixation of the gear ratio, the transmission may be classified into two. We call stepped and CVT, or continuously variable transmission. If you observe these 1, 2, 3 transmissions are stepped transmission, which means they have first gear, second gear, fourth, something like that. Even if it's automatic, we detect that when it's upshift or downshift, it will have some sound change. But on the other hand, the CVT transmission is, we call continuously variable transmission. It doesn't have limited speed. When we say limited speed, it doesn't have first, second, third gear. It's continuously varying accordingly with vehicle speed. In the next part, when we see the types of transmission we observe here, the manual transmission we will cover on this part, and the automatic we will cover on the chapter 4, and this dual clutch transmission and CVT, I will give you some clue on this. This dual clutch transmission, it uses 2 clutch pack, clutch 1 and clutch 2, for even and odd. If you observe this green, for second and fourth gear, it uses separate clutch, which is the green one, and for first, third and fifth gear, it uses the red. So it uses separate 2 clutches. Don't confuse with multiple clutch disc transmission and dual clutch transmission. When we say dual clutch transmission, it will have 2 pack, separate pack, clutch 1, clutch 2, but when you say multiple, the number of disc and plate will be increased. So that's one concept. CVT means it uses pulley, and it will increase its speed by means of hydraulic or another mechanism like tri-dual hydrostatic principle. Before we proceed to the gearbox, let's have some overview on the gear arrangement. If you observe, gears are the preferable power transmitting mechanism, as we cover in chapter 1, because they are applicable in different area. If you see this one is per gear, they are applicable in reverse gear, sliding mesh gearbox. This helical one, it's applicable in constant mesh gearbox and different gear drive mechanism. Worm gear in string system, speedometer application. This one, bevel gear in differential application. Mostly this double helical gear applied in heavy duty machineries, and hypoid gear applied in differential or final drive, and this rack and pinion is applicable in the steering system, and rotary and reciprocating mechanisms like door lock actuator mechanisms, and this planetary gear, which is the smart gear system, employs mostly in automatic transmission, and in some cases for electric vehicle it applied on as a power splitter device. When you see the power flow, the construction of and the operation of manual transmission, to observe this one, a manual transmission mainly consists of the power transmission, shift system, and lubrication system, and as a whole it's covered by the case. When you say the power transmission mechanism, there are input shaft, the output shaft, gears, bearings, synchronizer, and differential mechanism they use as the power transmission mechanism. The differential included in the transaxle. When you say shift system, they are assist the shifting of and the gear selection mechanism, shift forks, gear shafts, shifter shafts, and self-lock devices and interlock devices are employed. The lubrication in the case are the other issue. So as you observe, different parts are here. Here the shifting mechanism are here, the shift handle, including the fork, something like that here, and the power transmission mechanism. If you see the input shaft here, the counter shaft here, the output shaft here, the gears, the synchronizer, the Doctis mechanism are employed here. Also the case and the wheel housing, which covers the overall structure of the gearbox. When you see the main type of manual change gearbox, we can classify into two parts. The first one, it's according to the gear changing process. The first one is, we call that moving gear, because to select upcoming gear, whether in this part the gear is moved, but in this part the link mechanism, a moving link member mechanism, we call this one, the link mechanism will move from the system. So when we see this one, we call in another hand sliding mesh gearbox, and constant mesh and synchro mesh gearbox are categorized under moving a linking member. So these are engaged and disengaged by moving the linking member, not the gear. Always the gears are fixed and constantly meshed together here. So this is performed by means of control collar mechanism, by means of shaft spline and Doctis. So this is one thing. When we come to the synchro mesh, it uses conical part for the synchronization. We will see in detail this one. Components of manual transmission, it will separate in three parts. The extension housing over here, the clutch housing, and the gearbox housing in between. So these are the basic structure of the gearbox. So the input shaft, the counter shaft, the output shaft. So this is the basic thing. Of course, the input shaft, also known as the main drive gear or the clutch shaft, because it obtains power from the input shaft. The counter shaft, it holds the gears that mostly the gears are cast together with the shaft, and the output shaft, also we call this one main shaft. It will transfer power to the propeller shaft. The gears, we have forward gear, reverse gear, and speed gears. It will categorize different specific parts. The bearings, we will use different types of bearing, because the main shaft gears are supported by bearing to make different speed on the constant mesh gearbox. Maybe the bearings or the bushing will maybe one piece, split needle bearing, pilot bearing, or ball bearing, roller bearing are employed in overall gearbox operation. One key part for types of gearbox, especially types of manual gearbox, is the synchronizer. If you see, the synchronizer is, as the name indicates, it synchronizes the upcoming speed to the recent speed, which means if the driver try to shift from third to fourth, it will synchronize both speed before proper engagement is takes place. So it reduces the noise, because one disadvantage of the slide mesh gearbox is they was noisy and they cannot easily shift. Then they will try to use the helical gear instead of spur gear, and also this spur gear, helical gear also have some engagement problem because they use dog teeth. So to reduce that, in addition to dog teeth, it uses synchronizer, as you observe here in this part. So the synchronizer with conical clutch, if you remember in the classification of clutch, they use conical part and they will create friction to make balance of two gears. Let's see the operation of synchronizer. It will have 3 stages of operation. The first stage, we call that one initial synchronization, stage 2 synchronization, and the third phase is synchronized mesh. So if we see the first phase, which means initially when the driver selects the speed gear, the synchronizer assembly a little bit pushed by, and it goes in the conical surface. So in the first phase. In the second phase, it will try to, if you observe this clearance, it will have clearance, but it's reduced. In the third part, when the speed is synchronized together by means of frictional force, the hub will be passed through on this part. Let's see some video on this, very short video. Look, let me make it off. So synchronizing means one is integrated with the shaft, the other is integrated with the gear. So by integrating both, you see, the speed will become okay. If you see this detail animation, at this time the gear is free. When the driver pushes, the speed of both parts will become equal. You see, now it's equal, now it's different. So when they are equal, it can easily engage with this speed gear, you see. So the synchronizer did this synchronization before the gear is selected. So before we proceed to the power flow, the input shaft, intermediate, and output shaft are used. The bottom is the counter shaft. As I told you, they are separated by 3 basic parts. Thank you for your attention. As always, if you have any comment, you can address, or you can use these contacts, and I'm ready to answer your question. Thank you. Have a nice time.